Welcome back to my channel. This is Maluk, once again, your online educator. On my previous video, we tackled what the five senses are. Now, we're going to continue discussing each of the senses. We will start with our sense of touch. Let's proceed with the discussion. Enjoy and learn new things on this video. What is the sense of touch? The sense of touch, also known as tactile sense. It is controlled by our body's somatosensory system. It is a network of nerve endings and touch receptors in the skin that enable us to feel sensations. Our tactile sense helps us navigate our surroundings, identify objects by touch, detect different temperatures, determine varying pressure, and feel pain. It can include soft, hard, smooth, rough, hot, cold, pressure, pain, tickle, itch, vibration, sticky, slimy, wet, dry, and etc. The first sense to develop in a human fetus is touch. At 8 weeks, a fetus responds to touch of the lips and cheeks, with other body parts responding by 14 weeks. Infants use touch to learn about the world around them and to bond with others. Positive touch assists an infant's healthy development. The skin is the largest organ in the human body and houses receptors that sense touch. The skin of an average adult, spread out, takes up the same space as a single blanket. Now, how touch works. We can perceive things by touching, tasting, smelling, listening, and seeing. The sensory system that allows us to feel is called somatosensation. Somatosensation is a broadly defined perceptual system that involves, among others, the experience of being touched or stroked on the skin, but also sensing temperature and feeling pain. In addition, somatosensation is responsible for registering the inside of the body. This system allows us to know where our body parts, like your hands or feet, are located in space and is called proprioception. The latter is crucial for programming our motor behavior. We need to know even in the absence of visual feedback, where our body and limbs are in order to perform the correct movements. Finally, we can recognize objects by tactile exploration. Just think of trying to identify the contents of your pockets by feeling them or to open a door with the correct key in the dark. Since our skin is the largest organ in our body, it is made of layers of flat, stacked cells laid down into thin sheets. The three layers of the skin are the outer epidermis, middle dermis, and inner hypodermis. Skin constantly renews itself by new skin cells pushing upwards, causing older cells to fall off. Skin also contains nerves, sensory receptors, sweat, and oil glands and hair follicles. For our ability to touch, it is controlled by a huge network of nerve endings and touch receptors in the skin known as the somatosensory system. This system is responsible for all the sensations we feel: cold, hot, smooth, rough, pressure, tickle, itch, pain, vibrations, and more. Within the somatosensory system, there are four main types of receptors, and these are the mechanoreceptors, thermoreceptors, pain or touch receptors, and proprioceptors. Thermoreceptors. These receptors perceive sensations related to the temperature of objects the skin feels. They are found in the dermis layer of the skin. There are two basic categories of thermoreceptors. These are the hot and cold receptors. Cold receptors start to perceive cold sensations when the surface of the skin drops below 95 degrees Fahrenheit. They are most stimulated when the surface of the skin is at 77 degrees Fahrenheit and are no longer stimulated when the surface of the skin drops below 41 degrees Fahrenheit. This is why our feet or hands start to go numb when they are submerged in icy water for a long period of time. While hot receptors start to perceive hot sensations when the surface of the skin rises above 86 degrees Fahrenheit and are most stimulated at 113 degrees Fahrenheit. But beyond 113 degrees Fahrenheit, pain receptors take over to avoid damage being done to the skin and underlying tissues. Thermoreceptors are found all over the body, but cold receptors are found in greater density than heat receptors. The highest concentration of thermoreceptors can be found in the face and ears. Hence why your nose and ears always get colder faster than the rest of your body on a chilly winter day. Touch receptor and the pain receptor. The scientific term for pain receptor is nociceptor. Noci in Latin means injurious or hurt, which is a good clue that these receptors detect pain or stimuli that can or does cause damage to the skin and other tissues of the body. There are over 3 million pain receptors throughout the body, found in skin, muscles, bones, blood vessels, and some organs. They can detect pain that is caused by mechanical stimuli like cut or scrape, thermal stimuli like burn, or chemical stimuli like poison from an insect sting. These receptors cause a feeling of sharp pain to encourage you to quickly move away from a harmful stimulus such as a broken piece of glass or a hot stove top. They also have receptors that cause a dull pain in an area that has been injured to encourage you not to use or touch that limb or body part until the damaged area has healed. While it is never fun to activate these receptors that cause pain, they play an important part in keeping the body safe from serious injury or damage by sending these early warning signals to the brain. When your hand touches an object, the mechanoreceptors in the skin are activated, and they start a chain of events by signaling to the nearest neuron that they touched something. It detects stimuli such as touch, pressure, vibration, and sound from the external and internal environments. They contain primary sensory neurons that respond to changes in mechanical displacement, usually in a localized region at the tip of a sensory dendrite. Mechanoreceptor neurons are often surrounded by complex extracellular structures that couple displacement to the cell membrane, where mechanically activated ion channels create a receptor current. This neuron then transmits this message to the next neuron, which gets passed on to the next neuron, and on it goes until the message is sent to the brain. Now the brain can process what your hand touched and send messages back to your hand via the same pathway to let the hand know if the brain wants more information about the object it is touching, or if the hand should stop touching it. The resulting receptor potential is usually encoded into action potentials by voltage activated ion channels. Many of these mechanosensory neurons also receive efferent synaptic inputs from the central nervous system that modulate their sensitivity and possibly their dynamic responses. Proprioceptors. In Latin, the word proprius means one's own, and is used in the name of these receptors because they sense the position of the different parts of the body in relation to each other and the surrounding environment. Proprioceptors are found in tendons, muscles, and joint capsules. This location in the body allows these special cells to detect changes in muscle length and muscle tension. Without proprioceptors, we would not be able to do fundamental things such as feeding or clothing ourselves.